Okay, test. Okay, yeah, whatever. This is mechanics, chapter 6.1 to 6.4, University Physics level N. I don't even know, bro. Anyway, very easy. Work, power, time, whatever. So I'm just gonna start. A force F given by e to the negative 3x is where x is in meters is used to move a box between 1 meters and 5 meters. The work done by the force to the nearest integer is what? Okay, so you guys know work is equal to force times distance. Force times distance times cosine theta. Usually theta is 0 if it's just a horizontal force, right? So anyway, uh, basically now they call the distance, they call it x. Okay, so we say w is equal to f times x cos theta. Okay, very easy. So this is w is equal to fx cosine theta. In other words, the work is equal to integral f dx. Okay, from a to b. Okay, so this is basically the formula you need to know. So what does this mean? It basically means here, when you have any equation for a force, as you can see, it's not a number. It's not saying F is equal to 20 newtons. No, it's saying F is equal to e to the minus 3x newtons. So this is an equation that's variable. So depending on the x value, it gives you a different force. So you can never use the equation fx cosine theta for that. Therefore, you need to know that work is equal to integral f dx. Okay, so what does this mean? I'm sure all of you know how to integrate. So integral from 1 meter to 5 meters. So from 1 to 5 of e to the negative 3x. Obviously dx. So it's gonna be, what's the derivative of what's the integral of e? You guys know it's just e divided by u prime, right? So from 1 until 5. In case you forgot, integral e to the u dx is equal to e to the u over u prime. Okay, plus c, of course. Okay, it's just in case anybody forgot. This is the rule for integral of e to the power of u. Anyways, so you get this, and you just put it on a calculator over here. That means e to the negative 3 times 5 over negative 3 minus e to the power of negative 3 times 1 over negative 3. Let me just put it in a calculator. If you have this in the exam, by the way, don't waste your time and do it. Just throw it into a calculator like how I'm doing now, okay? Since integral calculators are allowed for mechanics, there's no reason for you not to there's no reason for you not to use the integral function. You have it on your calculator for a reason. It's not a math exam, it's a mechanics exam. Okay. Anyway, so this is the answer, 0.0165 joules. They want it to the nearest integer in millijoules, so we're gonna multiply it by 1,000. You get this. Okay, I got 17. 1 second. Okay, yeah, I checked it. It's wrong. It should be 17. Not 170. Okay, so the nearest integer, if you round this, you get 17, not 170. Okay, moving on. Question 2. Mark exerts a constant force of magnitude 150 to move a crate over 5 meters, okay, at an angle of 60 degrees to the direction of motion. What is the work? So this is very easy. Here, you might ask, okay, why don't you do integral f dx? This rule for integral f dx from a to b for the work is only used when f is a varying force. Okay, and when we say f is a varying force, they usually say it in the question, or they say f is equal to 3x. Whenever they give you any function of f, that means it's changing, so it depends on x. Okay, the equation w is equal to f times d times cosine theta, or fx cosine theta. This is when f is a constant force, and they usually say it in the question. Okay, anyways, so I don't know, there's no other equation that you can use here other than f d cosine theta to find the work. So we're going to put 150 times 5 times cosine 60, and you should get 375. Yeah, you get 375. The paragraph below describes when the work done by a force is positive, negative, or 0. Drag and drop. So when the angle between the force vector and the displacement vector is less than 90, the work done is positive. So when is it positive, when is it negative, when is it 0? So I'm going to draw for you 3 cases. This is your object. I'm going to put the force like this. We're going to put the angle as 25 degrees. I'm gonna draw one like this. Okay, the angle is 90 degrees. And one like this where where the angle is, as you can see, you guys know that the angle is always measured with the positive x-axis. So over here, this is about 100 30 degrees. Okay, anyway, so in these cases, what will the value of the work be? Remember, W is equal to F times X times cosine theta. So let's check. The sign of the work depends on, well, cosine theta. Because if theta is less than 90, cosine of any angle less than 90, if theta is less than 90, will be positive, right? So that means the work will be positive. طيب, okay, if theta is equal to 90, then cosine theta is equal to 0, and therefore the work is equal to 0. Because if cosine theta is equal to 0, then W is equal to fx times 0, which is just 0. And if theta is greater than 90 degrees, then cosine theta will be what? Negative, and therefore the work will be negative. You can try this if you want, using these three cases. Cosine 25 is a positive value. Cosine 90, I think you all know, 0. This is why, by the way, they ask sometimes, they give you like an FBD, and they ask you which forces do 0 work. It will be the forces that are perpendicular to the object, okay? Anyway, cosine 90 is 0, and then cosine 130, as you can see, is negative, okay? So it's equal to 9, when is it 0? When the angle is equal to 90. When is it negative? When the angle is greater than 90. And when is it positive? When the angle is less than 90, okay? Question 4. The speed of a free falling stone with mass 2 kilos changed from 3 meters per second to 6 meters per second. What is the work done by gravity along the mentioned path? So let's take a look here. You have the speed of the free falling stone. You have it changed its speed, right? So the speed is changing, and they want you to find the work. So in general, whenever you have the speed changing, then obviously kinetic energy is changing, right? When we say this, we say that work is done, right? Some sort of work is done. Okay, such that the work done by any force is equal to the change in kinetic energy. And this is what is called the kinetic energy, work kinetic energy theorem, work energy theorem. Okay, so, and I really don't like using this. If anybody does AS mechanics, they know that you use this a lot. You use this a lot, which is basically the work energy theorem, but a bit simplified. But for the case of, for the sake of Sabbath and keeping things easy right now, we're just going to use work. Anytime you see work and any change in speed, خلاص, work is equal to change in kinetic energy. So the work will be equal to K final minus K initial. So it's going to be half the mass 2 times velocity final is 6 squared minus half the mass times velocity initial, which is 3 squared. And you should get 27. You get 36 minus, 27. Question 5. An elastic force F is used to stretch a spring from 8 to 16. A graph of the dependence on the elastic force is shown below. What is the work done by F? So usually we know that the work done for any spring is half kx squared, right? I don't know if it was given in this, but usually this is what we use, right? But we don't know the k, we don't know anything about the spring, except they gave us a graph, okay? And what do we know? The work is always equal to the area under the fx graph, okay? And this is, by the way, this is the same as saying work is equal to integral f dx, okay? This is the same thing. These two are the same thing. Whenever you have area under something, it means it's also equal to integral of that, by the way. Anyways, so they give us the graph. Let's just find the area. Nothing too hard. Over here, let's see. From 8 to 16, so we would want to find this area over here. So this is obviously a trapezoid. Its base over here, this is base 1, which is 40. Remember, the area of a trapezoid is b1 plus b2 over 2 times height. Base 1 is 40. Base 2 over here is 20 over 2 times the height. The height of the trapezoid is 8. Okay, so 60 over 30 times 8, 204. Oh, this is in centimeters. So this should be 0.4 and this should be 0.2. So you get 0.3 times 8. Yeah, 2.4 joules. Okay, one thing that people still continue to get confused on is, okay, they figure out this is a trapezoid, but they don't know what to use for the base, what to use for the height. Always the bases are the sides that are parallel to each other. So these two sides are parallel, so they are the bases. Okay, and the height is just the distance between them. Anyways, question 6. The work needed to stretch a spring having a force constant equal to 40 kilonewton per meter by 0.5 centimeter is how many joules? Okay, obviously, work for a spring is half times k times x squared. So this constant here, 40, it's in kilonewtons per meter. And for it's worth note, you need to know that the constant should be in newton slash meter. So we can't work with kilonewton slash meter. So what will we do? We're going to divide by 1,000 to get rid of this kilo, right? So 40 divided by 1,000 newton slash meter, which is just cancel. You're going to get 0.04 newton slash meter. So your k value is equal to this. This is what we're going to use. And 0.5 centimeters, you know that we can't have it in centimeters. We have to make it what? In meters. So 0.05 meters. So let's go half times k 0.04 times 0.05 squared. I don't know how this is going to end up with 0.5, but let's see. 0.5 times 0.04 times 0.05 squared. Yeah, and I'm saying there's no way. Okay, فما dumbass forgot how to convert from kilo to normal. I don't know why I'm dividing by 1,000. يعني 1 kilogram is not 1 divided by 1,000 grams. Okay, I don't know how I forgot that. So to go from kilo to normal, you multiply by 1,000, sorry. Okay, and كمان 0.5 centimeters in meters is not 0.05 meters. So that's another thing that I made a mistake in. So this here becomes 40,000, 1, 2, 3, newton slash meter. And this here, if you divide by 100, you're going to get 0.1, 2 zeros, 0.005 meters. Okay, so it's going to be like this. وهيدي كمان over here, this is going to be 40,000, 1, 2, 3. Okay, now when I put this on a calculator, I should get this correct. So let's fix this, put another zero here, and make this 40,000.
So we lost?
1, 2, 3. You guys have. Okay. My fault. I'm slipping up way too much. بس خلاص, it's okay guys. بنقول إياه. Using a force of 80 newtons, a man raises a bucket of water steadily from a well 10 meters deep in 20 seconds. What is the power? Okay. Basically, if you have force and the distance, and you have time, remember that power is work divided by time. Also, if you see time, to find power, you have to use work divided by time. So we know that it's the force is 80 and the هيدا is 10 meters, okay? The distance is 10 meters. So obviously, the work can be found by doing F times X or F times D and cosine 0 because you're lifting it vertically upwards. So it's moving upwards and the force is going upwards, so the angle is 0 degrees. Anyways, over the time, which is 20 seconds. So the force is 80, the distance is 10, cosine 0 is just 1 over 20, you're gonna get 40 watts, okay? Don't forget units in your exam, please, but they're probably not gonna be written. This exam is not gonna be written. A scooter is moving at a constant speed of 36 kilometers per hour under the action of a constant traction force of 250 newtons. What's traction force? I don't know. Okay, what is the power? Okay. Remember that power is equal to force times velocity. The velocity is kilometers per hour, but we must make it meters per second. So 36 kilometers per hour. To make it a meter per second, you divide by 3.6. Okay. So it's gonna become it would be 10 meter per second. So therefore, the power is equal to the force 250 times 10, which is equal to 2,500 watts. In kilowatts, you divide by 1,000, so it's going to become 2.5 kilowatt. Okay. Question 9. A 10 kilogram block is attached to one end of a 3 times 10 to the power of 2 Newton meter spring. Remember, Newton meter is the constant K. Okay, so anytime you see it, that's what it means. A force F of magnitude 4 times 10 to the power of 2 newtons is applied on the block, and the spring is stretched by 20 centimeters. What is the total work done on the block? So we have a spring here, and we want to like pretty much find the work that's happening now, right? So please don't multiply the force by the distance. Wait, no, maybe.
I know that's what.
Yeah, please don't do force times distance. It probably won't work here. Okay, not probably. It won't. Well, let's try it. 4 times. Yeah, it won't work. Okay, you can't do it. So remember, for a spring, what's the rule when you have a spring to find the work or energy? It has to be half kx squared. So this is the work. So we have our k. We know it's stretched by 20 centimeters. Let's take a look here. Maybe do we get the answer? 0.5 times k, which is 300 times x squared, so 400, 0 0.2, no, 20 centimeters, 0 0.2 meters square. Let's see. Okay, we get 6. Yeah, that's definitely wrong. Okay, so what I found now, the 6, I found the work done by the spring. Okay, and that is 6 joules, right? So they want the total work done on the block. Okay, so this is very important here. You want to find the work done on the block, not on the spring. So it's very important to know, what they're asking for, because if they want on the spring, then 6 joules will be your answer. So let's just look at the block for now. We have the FBD of the block is like this. You have a force F. As you can see, the force is acting horizontally. It's not acting up the plane. Okay, so it's acting horizontally. Okay, you have the weight going downwards, obviously. Okay, and you obviously have, I don't know, normal reaction. Right, I'm just going to call the normal reaction R. And you have the tension of the spring, right? You have the spring's tension, right? So we have these forces acting on our block over here. Let's resolve our forces into Fx and Fy, and over here Wx and Wy. So it's important to know, you don't have to do this step. You could just find like, you can just see how do you do it. Also you can just find the work done by each force. But then I just did this to understand. So you know what, actually for you guys, I'm not going to resolve. Just keep it as it is. So you have the force like this, 30 degrees. You have the normal up. You have the weight down. You guys know that this is 30 and this is 60 over here. Okay, and you have your tension over here in the spring. So we have 3 forces, R, F, W, and T. So obviously, to find the total work done on the block, you find the work done by each one, right? So we already found the work done by the spring. It's 6 joules. So we're done. We're done that. We're done this one. Okay, the spring, the tension, we're done. Let's find the work done by the force F. We know that the force F is 4 times 10 to the power of 2 newtons. So let's just say 400 newtons. Remember, work is equal to Fx cosine theta. Okay, theta, x, the distance traveled, is 20 centimeters, so 0.2, times theta, which is 30 degrees, right? It's with the positive x-axis, it's making 30 degrees. Okay, it might be negative 30 degrees, but it's fine. You can just say cosine negative 30. It doesn't matter. 30, negative 30, doesn't matter. You can get the same answer. So you can get the work done by the force is 400 times 0.2 times cosine 30, which is 69.3. Yeah, 69.3 newtons. Okay, and you're also gonna see now for the weight. The work done by the weight is equal to what? Again, F times X times cosine theta. The force of the weight, you guys know that weight is equal to mg. W is equal to mg, right? The distance traveled, again, is still 0.2 meters. And theta is going to be 180 degrees plus 60. Okay, so we're going to write it down like this. 180 plus 60. And then cosine of that. Okay, so you get... Sorry, you don't take 180 plus 60. My fault, you don't take this angle. You always go with the positive x-axis, okay? So you go from here. You don't go like this. You take the shorter one. You don't take, like, over here with the weight, you have this angle. Okay, and you have this angle over here, right? So we're going to take the smaller one. You always take the smaller one. Okay, so that's 90 plus 30, so 120 degrees. Okay, so mg times the distance times cosine 120. And you're going to get... over here, the mass is 10, g is 10 over here, times 0.2, so 10 times 10 times 0.2 times cosine 120, you're going to get a negative value, of course, so you're going to get negative 10 joules. I don't know why I put this in newtons, it should be joules. Okay, now, what else do we have? We have the work done by the normal reaction, which is obviously just 0. Why? Because obviously it's perpendicular. Perpendicular forces don't do anything. Okay, anyways, this here, before I move on, the work done by the spring should be negative, and I found the work done on the spring. The work done by the spring is always equal to the negative work done on spring. Okay, I just want work done by spring is always equal to negative work on spring. Okay, so we're going to just say negative 6 joules. Okay, so now what do? We just add these up. You're going to get 69.3 minus 10 minus 6. You're going to get 53.3. Okay, very easy. If you want, you can... What I originally did, by the way, before, like off camera, is I didn't work with negatives or positives. I drew the FBD, like look over here. I drew the FBD. I figured out that these are the forces acting. Like this, you have the force F, which is 30 degrees, and you have weight, and you have a tension, right? And you have, it's obviously moving up the plane, so it's in that direction. Okay, sorry, the weight was like this. Over here, 30 degrees. So what I did is, over here, I did the weight's obviously making angle 60 degrees over here. I found the work by each one. I didn't work with any negatives or anything. I found the work by each one, and then I just said, oh, I'll just get the work on this side, the work on this side, and then subtract them from each other. You can do that, or you can do how I solved now. I think this way is easier over here. You know, it makes more sense, you know. Anyways. Moving on. Question 10. So, this question here, it's interesting, صراحة. So you have the mass of the crate over here, and you have these two forces in the diagrams. So you have this force acting 30 degrees like this, and this force acting 45 degrees upwards. They're saying the coefficient of kinetic friction is 0.2. What is the distance covered by the crate when its speed is 8 meters per second? So there's one thing that you should know is how can you relate speed, mass, so you have mass and velocity. How can you relate it to force and distance? If you remember force and distance, what does force times distance get you? Work, right? And when you have mass and velocity, you have kinetic energy, because remember kinetic energy is half mv squared. So we know that we can relate kinetic energy by work by saying work is equal to the change in kinetic energy, remember? So let's do this now. Actually, let's find the kinetic energy. It starts at rest, so the initial kinetic energy is obviously 0. So the change in kinetic energy is equal to kinetic energy final, obviously, which is half times the mass. Oh, that's not half. Half times the mass, which is 100, times the velocity squared, so 64, and you're gonna get 32 times 100, 3,200 joules. Okay. Okay. We now have two forces, one like this and one like this, and they're saying that there is a coefficient of kinetic friction. Okay. So let's find the force, right? So remember, we're going to relate work is equal to the change in kinetic energy, and we know work is equal to force times distance. So when we can figure out what this force is, we can just simply solve it, right? So what is the resultant force over here? We have our object accelerating to the left, and you have obviously you have friction, right? Why do we have friction? Because they said that there is friction. They said the mu k is 0.2. So obviously here we need to figure out what's the force done by friction. Okay, so let's draw our FBD for the block, just so we can understand what's going on. Okay, you have over here, you have the weight obviously going down. The weight going down, W. You have friction, right? It's called Fk. You have the reaction force, normal reaction upwards. I call the normal reaction R. And you know what? I'll just call it N for the sake, because you guys don't use N. And then to the left, you have two forces. You have one 45 degrees upwards, right? So you have, let's call this F1. And you have one that is 30 degrees downwards. It would be 30. Let's see. Yeah, but it's going to be 30 degrees for F2 as well. Why, by the way, is because these lines are parallel to each other. So that means this angle here will also be 30 degrees. And then since these are vertical angles, so this will also be 30 degrees. Okay, anyways, so F2 over here going 30 degrees downwards. Okay, it's an annoying diagram to work with, but خلاص, it's fine. So what's going on over here? We know that, where is this? We're trying to find the resultant force, right? The resultant force on the work. So to do this, here's what I am gonna do. I don't know about you guys. Maybe you do a separate method, but I'm gonna use the horizontal component of the force, because the work only takes the horizontal component, right? So over here, what are my horizontal forces? I'm gonna resolve these into F1x and F2x, right? Over here, and F2x. So why am I doing this is because I want to see what's the net force. right? Because work is equal to force times this 3,200 is equal to the work force times distance. I want to know what this force is. What's my net force, right? So to do that, some people they do the work plus the work done by friction. I don't know. Maybe you do that. Anyways, my point is, and I like doing it. One equation, change of kinetic energy is equal to work, which is 3,200 equals to the force times the distance. We want to find this distance. We have a lot of forces, so we just need to find out what the net force is. Some people will go and add up 400 and 300, they're going to get 700, and then subtract friction, which is completely wrong. Why is this completely wrong? Because what forces do work? What forces do work? Only the horizontal components. Okay. Or some people maybe they do like they don't think about horizontal component. They just have the rule memorized: F times cosine of the angle, which is the same as just finding the horizontal component. Okay. So take this as a rule for you. You know, the only forces that do work are the horizontal forces. Okay. Anyways, so what is sigma fx? I want to know what is my resultant force. Sigma fx over here will be f2x minus plus f1x minus friction, right? So f2x will just be f2 we said is the one down 300, right? So 300 times cosine 30 plus f1x is 400 times cosine 45, okay, minus friction. Okay, so this friction is where stuff gets a bit tricky. So friction, remember, is equal to mu times n. So in this case, it's going to be 0.2 times n, and we need to find n. And I'm pretty sure all of you remember, or not all of you, most of you remember that to find the normal, we always go back and we do sigma fy is equal to 0 to find the normal. So what are my vertical forces? I have n plus f1y. Most people forget this, huh? They forget to resolve vertically as well. f1y and f2y over here.
Check.
So n plus f1y is equal to the forces acting downwards, f2y plus w. And we can solve for n. How do we do it? N is going to be equal to f2y, which is over here. f2y is 400 times sine 30 plus the weight, which is the mass of the object, 100 times g, which is 10. Remember, w is equal to mg. This is why I did this. Okay, minus, because we took f1y to the other side, is going to be f2y plus w, which is 400 sine 30 plus 100 times 10, minus f1y, because we took it to the other side, so minus f1, which is 400 sine 45. I don't know why I put 400 here. This is supposed to be 300. Sorry, huh? Okay, if you do this on a calculator, you're gonna get let me do this over here. 150 plus 1000 minus 400 sine 45. Get 800 something. Yeah. So you get this. So you're gonna get friction is equal. Sorry. You're gonna get n is equal to 867 newtons. Okay. So we know n is equal to 867 newtons. So now over here in friction, we can substitute the n back in. So it's gonna be 0.2 times 867, and you're gonna get 173.4 newtons. So this friction is 173.4 newtons. Okay, so back here to find the resultant force, we can now substitute our friction back in. So I'm gonna go over here. So 300 cosine 30 plus 400 cosine 45 minus fk, which we found, friction, which we found as 173 point. Why is this going down? 173.4. Right? So let's put it in the calculator. 300 cosine 30 plus 400 cosine 45 minus 173.4, and you get this. So this is your resultant force. Sigma fx is equal to 369.3, okay, newtons. So now we know our resultant force. We can just substitute back here. So 3200 is equal to 369.3 times d, and you can solve for d by dividing by this answer. So 3200 divided by answer, and you get 8.67 to the nearest decimal place, second decimal place. Okay, not too hard. Just figure out all your resultant forces and use the work energy theorem. But remember, this is fx. Okay, it has to be fx. Anyways, question 11. A 30 Newton box denoted by A over here, okay, is released. A 30 Newton box, give 30 Newton. Maybe the weight is 30 Newtons. Is released from rest and slides down along a smooth ramp onto the surface of a cart. Okay, the diagram is very small for me. I can't see well. The coefficient of kinetic friction between the cart and the box is equal to 0.6. What is the distance s from the end of the cart where the box stops? Okay, so we have a box over here, 30 newtons. It's sliding down a ramp which is 4 meters high and it's smooth, so there's no friction here. And then it goes over here onto a ramp and stops over here s meters away from the end. Okay, we need to know that this is a rough cart. So over here there's friction. See, there's no friction because he said it's smooth. So let's take a look over here. So to understand what's going on over here, I said, you know, it goes down, it speeds up. So it's now moving at a speed, it's speeding up, and then since there's friction, it comes to a stop over here, s meters from the end of the box, end of the cart. So to understand what's kind of visualize what's going on, I want you to better understand what am I saying. Okay, when the object comes down here and stops at A, okay, it has a speed v. Okay, I'm just so like I want you to kind of understand what I'm saying when I solve. So it comes down here, it stops, not stops, it comes and changes direction, and it would have v meters per second. Why does it have v? Because it's falling down. Okay, obviously it's speeding up, right? It comes here and it starts to slow down, and it ends over here where v is equal to 0 meters per second. So there's actually many ways you can solve this question, but since we're working with work and I don't know what, I'm gonna use, again, since you're changing kinetic energy, there's obviously gonna be work done. Work is gonna be equal to change in kinetic energy. Okay, and what's the force that's applying this work to slow down the box over here? Friction, right? So work by friction is equal to the change in kinetic energy from here to here. And what do we know the work, what's work equal to? It's equal to Fx times the distance, right? So if we can figure out the change in kinetic energy, and we can figure out the force of the friction, because they gave us the coefficient of friction, we can easily find the force of friction. Remember, friction is equal to mu times n. Then we can just divide them and find the distance. So let's take a look over here. The first thing I'm going to do is I'm going to find the change in kinetic energy. So kinetic energy initial is equal to, over here, from here till here, okay, from here till here, is equal to v, and kinetic energy final is equal to 0. Not 0, sorry, not v. I don't know. We don't know what it is, right? We know that it's equal to half times the mass times velocity squared, right? We know that. طب أول شيء let's find out the mass. They told me that the weight of the box is 30, so W is equal to mg. We know g is 10, so the mass is just going to be equal to 30 divided by 10, which is 3 kilograms. Okay, so it's equal to half times 3 times the velocity squared. This v is the annoying part. You need to know how much is this v. Remember that our box is coming from a height over here, and it accelerates all the way here. The height is 4 meters, so we can easily find out what the velocity is. If you remember, mgh is equal to half mv squared, right? For any object that's falling down, some people, they just memorize it as v is equal to root 2gh. For any object falling down, if it starts from rest, then the final velocity will be equal to root 2gh. Some people have it memorized, but where does this come from? It comes from here. mgh is equal to half mv squared. Cancel m with m, right? Because here it has potential energy, here it has kinetic energy. Here, since it's starting from rest, it has 0 kinetics, so that's why we say that the energy at that instant is mgh. Then here, since the height is 0, there's no more mgh, but it has a velocity, so we say the energy is half mv squared. So if you equate them to each other, since the energy is conserved, m with m cancels, you're going to get that v is equal, multiply the half on the other side, you're going to get 2gh is equal to v squared. So you're going to get v squared is equal, v is equal to what? Root 2gh. So how do we find the velocity now? We know that it moved by a height of 4 meters. We know that g is 10, so we just put this on our calculator. You're going to get 4 root 5 meters per second. Okay, so now can we find our kinetic energy? Yes, we can. Half times 3 times 4 root 5 squared. Okay, let's take a look. 0.5 times 3 times 4 root 5 all square. You're gonna get 120 joules. Okay, so nice. We got our initial, we got our final. So we can now work the work done by friction is equal to the change in kinetic energy. So 0 minus 120 joules, which is negative 120. And we know this is equal to the force of friction times the distance. Okay. Why, by the way, is this work by friction? Because the only horizontal force acting here is friction, which slows down the block. There's no accelerating force. There's nothing being applied. It's just friction, guys. Okay. Anyway, so let's find the force of friction. If the object is moving to the left and friction, if the object is moving to the left, so x is in the left direction, and friction is opposing it, we have the weight over here, right? And we have the normal reaction. So we know that F is equal to mu times N, so it's equal to 0.6 times N. We need to find N. Always, when finding friction and you don't know what N is, you have to go back to sigma Fy and say it equals to 0. So N is equal to W. And what is the weight? It's given to us as 30 newtons, which is amazing. Okay, so it's going to be equal to 0.6 times 30, which is 5 newtons. But what's the catch here? It's moving to the left, but friction is opposing it. So what's the force of friction? Negative 5. Okay, so going back here, you're going to get negative 120. Wait. Yeah, and I don't know how I said it's equal to 5. I don't know in what world 0.6 times 30 is 5, but it's equal to negative 18 newtons. Okay, so I thought, no way 0.6 times 30 is 5. Anyways, so 0.6 times 30, you get 18, and since it's opposing it, we're going to keep negative. So negative 120 is equal to negative 18. Divide them, 120 divided by 18. You get 6.6, right? Someone's going to come and say, oh, what, that's not the answer. Okay, it traveled 6.67 meters, right? So how much is there going to be left? They say, look at what they're asking for. They're asking for the distance from the end, right? So since they told us that the whole thing is 10, you just do 10 minus 6.67. And you get 3.333, which is just rounded to 3.34. Okay, so I think everything here is pretty straightforward. You're just applying formulas. Maybe the negative part here is what some people may not understand. If you don't want to work with negatives, you can just take the absolute value of this answer. Even if it's negative, even if the change is negative, I'd just work with 120 and keep the friction positive. That's completely fine. Okay, but what I'm saying is, if you want to take this negative here, you have to account for whether the friction is going in the same direction. Okay, these are all things that play into your answer. In my opinion, it's best to take it negative and then put friction opposing it, so the value of friction should be negative. The way I did it now is what I would prefer you to do, because it prepares you for cases where there's a lot of forces and you have to see all frictions on the other side, so you have to make it negative. Anyways, question 12. A car has a weight of 7.5 times 10 to the 3 newtons and an engine of power 55 kilowatts to all the wheels. What is the angle of the largest incline that the car can climb at a constant speed of 30 meters per second? Choose the correct answer. So, the first thing we need to know is, well, they want the angle, and they gave us the velocity, and they gave us the power. So, obviously, you're going to kind of draw some sort of inclined plane FBD, and then go like, oh, the force is like this is going like this, there's an angle here, whatever, here, this, that, right? So, we're going to work with some sort of FPD. So to do that, let's figure out what is the force that our engine is transmitting. They gave us the power of it, and they gave us the velocity. Remember that P is equal to FV. So therefore, 55,000 is equal to the force times 30. You're going to get that the force is 55,000 divided by 30, which is, let's just say 1833.3. Okay, so F is equal to 1833.34 newtons. Okay, so to understand this, when they say constant speed, remember that means that sigma fx is equal to 0, right? So let's draw our FBD here. We're gonna draw it كأنه it's at an inclined plane of alpha degrees. We don't know what this alpha is, right? So we're gonna draw it. The FBD is gonna be like this, right? So you have your weight, which is acting vertically downwards at an angle of alpha degrees, right? We don't know how much it is. You have that the force of the engine, which I like to call dF, the driving force. And you have over here, you have what? You have the normal. And is there any friction? No, there's nothing. So these are only the forces acting. Let's resolve our W obviously into Wx and Wy. Type. Remember, they said constant speed, so that means sigma fx is equal to 0, and we figured out that the driving force of the engine is what? 1833.34 newtons. So if sigma fx is equal to 0, That means dF is equal to the Wx. That means 1833.34 is equal to Wx. What's Wx? It's mg sine alpha, right? It's the weight times sine alpha. Why? Because alpha is with the vertical, if I use sine for the x component. So 1833.34 is equal to the mass. They gave me the weight, so I don't even have to do mg. They gave me the whole weight already, so it's 7.5 times 10 to the power of 3 times sine alpha. So sine alpha. So can I figure out what sine alpha is and then just do shift sine? Of course I can. Sine inverse, or some people say arc sine, whatever. Anyways, I can figure out what sine alpha is equal to. So let me just divide 1833.34 by 7.5 times 10 to the power of 3. And I'm just going to get the value of sine alpha. And from there, I can just do sine inverse and find out what the angle is. So 7.5 times 10 3. So I'm going to get that sine alpha is equal to 0.24444. Okay, so sine alpha is equal to 0.244. Let's just round it to 445. Okay, so can I figure out what alpha is? Yes, I can. Shift sine. You get 14.1 degrees. Okay, so this angle is 14.1 degrees. So pretty straightforward. If they want constant speed, that means sigma fx is equal to 0. That's it. Okay, question 13. The steps of an escalator move with a constant speed of 0.6 meter per second. There are 32 steps, and each step is 125 millimeters high and 250 millimeters in length. Okay. What is the power of the motor needed to lift a mass of 150 kilograms along the whole escalator? So let's take a look here. So this one, Sarah, it's one of the more complicated ones. The past 6-7 questions are all like these long ones where you need to solve. But anyways, to do this, I want you to think of the escalators. I'm pretty sure most of you here, if you're in the UAE or any Gulf country, pretty sure you've been on an escalator before. You know, these escalators that kind of look like this, you know. Okay, anyway, so just so you can kind of see how the escalator looks, it's basically a stair that continues to move at a velocity, and that's given as 0.6 meters per second. Okay, so it's going up at this velocity. And what you need to know is that it's 125 millimeters high and 250 millimeters in length. So each stair has these dimensions. 125 millimeters. So let's just make it in meters and say 250 millimeters. That means 0.25 meters, and 125 high, so 0.125 meters. So this is how each stair looks. So there's 32 of these. So they all continue up and up and up and up and up. So what do we need to know here? They're asking what's the power needed to lift a mass of 150 kilograms along the whole escalator. So we want power. We have the velocity actually. Remember, P is equal to F times V. We have the velocity, so P is equal to 0.6 F. So the only thing we're missing right now is this force, so that we can figure out what the power is. So what is the force needed to lift a 150 kilogram object at 0.6 meters per second up all of this? So let's take a look. The first thing that I'm going to find is what's the height? How high did I raise it, right? So let's take a look. We know that the height of each stair is 0.125, and there's 32 of them. So let's do 0.125 times 32, and you get 4. So the final height is 4 meters. Okay? Here's a way that you can figure out what the work done is. Remember, work done is equal to change in kinetic energy, right? And here's something that they don't tell you, and I don't know why they don't teach it in AP, is this rule that I always use. ME1 plus work external is equal to ME2. This is basically the work energy theorem summarized in an easier way. Remember that mechanical energy 1 is equal to kinetic energy plus potential energy. Okay, I always use this. I never use work energy theorem because also حتى in the ones where you're using work energy theorem, this same formula works. Okay, so I like using this because it summarizes kinetic energy and potential energy and work all in one formula. Anyways, so we have ME1. We're starting over here. The potential energy is 0. The kinetic energy is half times the mass, 150, times 0.6 squared. What is the work external? We have an external force that we're just going to call it work external, right? We're pushing it up with that force. Equals ME2. At ME2, it's still, the kinetic energy is still half times 150 times 0.6 squared. It's still the same velocity, same constant speed, plus ME2, the potential energy up here. What is the potential energy here? mgh, right? So the mass is 150, g is 10, and the height at that instant is 4. We can cancel this with this, because if you subtract, they're just going to cancel out. So you're going to get that the work external is 150 times 10 times 4, which is 6,000 joules. Okay, so we know the work external is this force, we don't know what it is, times the distance is 6,000 joules. So can we figure out now what the force is? Of course we can. So what people will get mixed up is they're going to use the height here as the distance, which is completely wrong. The distance is what's the distance traveled, not the vertical distance. Vertical distance is what we call height, but when we're finding work, it's force times the distance. Now, how long did it travel? So let's take a look. To find this, obviously this would be finding the hypotenuse of each step. And since they're all the same step, we can just find the hypotenuse for one step and multiply it by 32, right? So let's find the hypotenuse. Using Pythagoras theorem, 0.125 squared plus 0.25 squared, you're going to get the hypotenuse squared. And to find the hypotenuse, you just square root that. So you're going to get root 5 over 8. Since we have 32 steps, we're just going to multiply this by 32, and you're going to get 4 root 5 as your distance. So F times 4 root 5 is equal to 6,000 joules. So very easy right now. All you have to do is just divide 6,000 by 4 root 5, and you're going to get 670.82. So we found now that our force is 670.82. Let's multiply it by our velocity to find the power. So 0.6 times 670.82. Yeah. So multiply this by 0.6 and you're going to get 402 watts, as you can see. Question 14. A 2 times 10 to the 3 kilogram car uniformly increases its speed from rest to 25 meters per second in 30 seconds along an inclined road at an angle of 5.7 degrees with the horizontal. What's the maximum power that must be supplied by the engine, which operates with an efficiency of 0.8? So this efficiency, صراحة, it's like زناخة. I don't know why they put it. It's just an extra step that's useless. Okay, so if we know that the efficiency is 0.8, that means power out, the actual power you're getting, is 0.8 times power n. So 0.8 times the power that's actually being supplied by the engine. Only 0.8 of it, 0.8 times of it, is being converted into useful energy. So whatever calculation you're going to get, that's obviously going to be power out. And then obviously they want you to find power in. In every case that we've worked with, power out is equal to power in, because ideally you'd assume that it's 100% efficient. There's no 0 point whatever. So the efficiency is usually 100% unless specified in the question. That means you have to do this extra step. So whatever power you get, you have to divide it by 0.8. So this power in is just going to be equal, after you calculate your power, you're just going to have to divide that power by 0.8. So let's do it. So you have an incline at 5.7 over here, 5.7 degrees. And you have a car. We know that it accelerates in 30 seconds. What is the power? So we have the time. So we're obviously gonna do power is equal to work divided by time. And we want to know what is the work needed to accelerate our car from 0 to 25 meters per second. So do we have a change in kinetic energy? Yes, we do. So we can just do that the work is equal to the change in kinetic energy. Not too hard, yani. Actually, no, you can't use work and change in kinetic energy. This is why, again, I don't even, like, if I were a teacher, I wouldn't even teach you this. Okay, I don't like it. It's very useless. Okay, it only works for the cases if you're horizontal and there's no external force. Okay, but when you go up an incline and whatever, it will not apply anymore. Right now, when you're at an incline, you will not only be changing kinetic energy, so the work will not be equal to the change in kinetic energy. For that reason, I'm not going to use work is equal to delta K. I'm going to use the same formula I used in the last question. I'm going to use ME1 plus work external is equal to ME2. I will always use this, even in the questions where the work equals delta K applies. I won't even use that. I'm always going to use this, because this will account for any change in potential energy as well, and that's extremely important. Okay, anyway, ME1, since we're starting from rest, the kinetic energy initially is 0, and since we're starting from this point over here, what am I saying? Yeah, since we're starting from this point, the initial potential energy is also 0. Okay, now you can add W external. You're gonna get ME2. What's ME2? You're now at a point here that's increased by what? A height. I don't know how much. Its mass is 2000. So 2000. Sorry. And what I'm finding here is the potential energy first. Potential energy plus kinetic energy. ME, mechanical energy, is equal to potential plus kinetic, right? To find the potential energy, you guys know it's mgh, right? So since the potential energy obviously changed, because why did it change? Because the height changed. So if it was a horizontal road, خلاص يا أخي, it's 0. Why? Because the potential energy didn't change. You're at the same height. But since you're seeing that it went up and inclined, you have to account for potential energy. This is why I'm saying that the potential energy is not 0, and this is why I'm using this formula here. Because if I use delta K, I'm gonna get the wrong answer, definitely. Okay, so ME2, potential energy, mass, times G, which is not given. We're just gonna use 10. Okay, times the height. This height we can find in a bit. Plus kinetic energy. Kinetic energy is gonna be half times the mass, 2000, times its velocity squared, 25 squared. Okay, so we can now find W external, but one thing is missing is that we need the height. Okay, we need this height. What do we know? We know that it went from rest to 25 meters per second in 30 seconds, so they give us the time. Can we find the time? Can we find the distance traveled? Of course we can. We have initial velocity, we have final velocity, and we have a time. And they told us that it's a constant acceleration. So how do we find the distance traveled? Obviously, we can use half AT squared. Actually, I paused to think about it. There's obviously a better formula you can use. You can also use this formula. If you remember the UARM formulas, there's 4. One of them, if you don't have the acceleration, but you have the initial speed, final speed, and the time, you can use U plus V over 2 times T. You can use this formula. This is also nice, عادي, because this way you don't have to take an extra step and find the acceleration. But if you don't know this formula, you forgot it, عادي. I'm sure most people remember the formula. Either you can do, when you find acceleration, if you find the acceleration here, it's going to be equal to velocity divided by time, right? So 25 divided by 30, which is, if you divide by 5 up and down, you're going to get 5 over 6. Okay, anyways, so this is going to be your acceleration. Now that you know your acceleration, your initial speed, final speed, and the time, you can use any of the UARM formulas, any one that you remember. You can use x equals half AT squared plus UT, or you can use V squared minus U squared is equal to 2AX. These both work. Okay, or you can use, like I said, U plus V over 2 times T. They all work. Okay, I'll just use this one to make my life easier. Why am I doing this? Is because most people will not remember the formula U plus V over 2 times T. But if you want to use U plus V over 2 times T, that's fine. You won't have to take this extra step and find the acceleration. Anyway, so x is going to be equal to half times 5 over 6 times the time squared. It's 30 seconds. Plus the initial speed, 0. So this is 0. UT is 0 since we started from rest. Okay, so you're going to get over here that this is, let's see, 0.5 times 5 over 6 times 30 square. You get 375 meters. So the distance traveled is 375 meters. So this is 375 meters. Is that the height? No, it's not. Okay, so we're still not done. We still haven't found the height. The height is always equal to L sine theta. Okay, or some people say X, I don't know. But المهم, the whole point is the height is equal to whatever length or distance you travel times the sine of the incline. Always. The proof of this is because it's a triangle. Right, it's a triangle. This is the height, this is theta, and this is the hypotenuse, right? You know, sine theta is equal to opposite over hypotenuse, so h over hypotenuse. So how do you find the h? It's just equal to the hypotenuse times sine theta, and the hypotenuse in this case is the length traveled. Okay, so h will be equal to this 375 times sine of 5.7. So now we can plug everything back in and we can work. So W external will be equal to 2000, because 2000 times 10, I just multiplied it and made it 20,000. 375 sine 5.7 plus half into 2000 times 25 squared. Okay, let's do it. We're gonna get 20,000 times 375 sine 5.7 degrees plus half into 2000 times 25 squared. you're gonna get this. This is a very long number, right? So we got what W external is. So I'm just gonna label this as answer because this is very long. Okay, so the power is this work divided by the time. So the power, what we're trying to find, is this answer divided by the time, which is 30 seconds, right? And you're gonna get 45663.27 kilowatts. 45663.2, let's just say 0.3 watts, right? So some people are gonna see this. They're gonna be like, whoa, that's the wrong answer. Don't panic, because if you remember, I told you, whatever power you're gonna get here, you have to divide by 0.8 to get the correct answer. Why? Because this is the power. This is power out. What we found now, any calculations you find, it will always be your power out. And we always assume that it's 100% efficient, so the answer will always be the same number you get here. But since they came and said that there's efficiency, 0.8, what do you have to do? You have to divide by the efficiency. So divide by 0.8. And you're going to get 57,079. They want it in kilowatts, so divide that by 1,000. And you're going to get 57.07. To the nearest decimal place, it will be 57.1. Okay. Question 15. A 50 Newton crate initially at rest uniformly accelerates, reaching a speed of 10 meters per second in 4 seconds. The motor has an efficiency of 0.65. So again, we have another question that involves the efficiency of the motor. What is the power that must be supplied when t equals 2 seconds? So this question is pretty much the same question as the last one, online, but this is صراحة it's easier than the last one. So again, they told you it's accelerating at rest, whatever they want you to find the power. وهذه t equals 2 seconds, it's pretty much, and it's stupid, okay? But power is always constant. Well, no, not really. But for our level, you're never gonna see a question where the power is varying, okay? So the power, it's gonna be by a motor, unless someone comes and changes and plays with the motor, it's gonna be constant. So at 0 seconds, 2 seconds, 4 seconds, you're still gonna have the same power, okay? So they just put this to confuse you over here. I'm gonna strike this through, and I'm just gonna work as if they're asking me what's the power, okay? So remember, we have our box here, it's being pulled up, it starts from rest and reaches 10 meters per second in 4 seconds. So we actually have the time, it's 4 seconds, and obviously if you want to find power and we have time, we're gonna want to find the work divided by the time. So we need to find the work. Very easy. We're gonna use the same method as last time. So we know it's being lifted upwards and it reaches a speed. So to do that, to find the work, remember always that ME1 plus W external is equal to ME2. Okay, so therefore ME1, since we're starting from rest and we're starting from the 0 height point, we're gonna call ME1 0, because the kinetic and potential are both 0. W external will just be W external, we're trying to find it. ME2, obviously, the kinetic energy after it stops is going to be 10 meters per second, right? So شو 10 meters per second قصدي is going to be half mv squared, and the velocity is 10 meters per second. Okay, so the kinetic energy will have times the mass. This is the weight, so please don't mistake and put the weight as the mass. No, if W is equal to mg, then the mass is 5 kilograms. Okay, because if g is not given, just use 10. Okay, so half times 5 times the velocity squared, 10 squared, plus the potential energy at that point will be the mass, again 5, times g, which is 10, times the height, right? mgh. So we now know that W external will be equal to all of this. What do we need? We need to find the height. You're going to find the height using the same method I used last time. Okay, since it's vertically upwards, the height is just going to be equal to the distance traveled, since you're going vertically upwards, right? So how do we find the distance traveled? Again, you can find the acceleration like I did in the last question, and then use x is equal to half at squared. You can use that, but you need to find the acceleration. Or you can use x is equal to u plus v over 2 times t, which works perfectly fine, okay? This way you don't have to find the acceleration. I'm going to use this one. Last question I used this one, this time I'm going to use this one. So let's see. Initially we had 0, because we started at rest. The velocity is 10, and over 2 times the time, which is 4 seconds, you're going to get 5 times 4, 20 meters. So the height is what? 20 meters. So therefore, you're going to take that 20, you're going to sub it back in over here. Half times 5 times 10 squared plus 5 times 10 times that 20. So what are you going to get W external to be? Let's do it. 2.5 times 100 plus 50 times 21,000. Okay, you're gonna get 1250. So W external is 1250 joules, right? I just put this in the calculator. طيب, how do we find the power? We just do work divided by time. So 1250 over the time, which is what? 4 seconds. Over here, there's no other force. It's just that force pulling it up, right? So 1250 over 4. And you're gonna get the power. But what do you need to know? Don't panic. Okay, it's not the correct answer. Don't panic. Remember that they said the efficiency of the motor is 0.65. So what does that mean? Power out is equal to 0.65 times power in. And remember, the value of the power that you find is always power out. So what do they want? They want the power in. This is the one supplied by the motor. So you're going to say power in is equal to power out divided by the efficiency 0.65. Okay, so let's divide this by 0.65 and you should get 480. Yeah, you get 480 to one decimal place. It's 480 point. To the nearest integer is 481. Okay. Question 16. And هاي الكويز مش راضي يخلص. A dragster. That's the first time I see this word. Dragster. A dragster's jet supplies a constant thrust of 20 kilonewtons. Neglect all frictions and the effect of loss of fuel. If the dragster has a mass of 1000 kilograms and starts from rest, what is the power generated by the jet as a function of time? So this is this question over here. You rarely see questions like this where they say write it as a function of time. It's it's a stupid question. But you guys know P is equal to force times velocity. And they gave you the force. You just need to find the velocity. But this way, it's not a function of time, right? So what would you need to do is you would want to write power as, I don't know, let's say a variable times time, okay? One way I looked at this is I started thinking, is there any way I can express force as something times time? Is there any way I can express velocity as something times time? And then it hit me, I was like, oh, okay, velocity is just acceleration times time. So you can rewrite all of this as F times A times T. So if you want to write it as a function of time, it will just be P is equal to FA times T. So what is, the force is 20. Sorry, is the force 20? Yeah, the force is 20. But what is the acceleration? Yeah, what's the acceleration? We need to find the acceleration. So in case you don't know, a jet, I thought it's a rocket, يعني going up, because it's a dragster jet. But I had to Google this. Apparently, a dragster is like one of the race cars. Its direction of motion is horizontal. Okay, so over here, the dragster is accelerating to the right. Okay, you have the force over here. We're gonna call it the driving force. You have the weight. So it's just these two forces. So obviously we can find the acceleration very easily by just doing MA. Therefore the driving force is equal to MA, and the driving force is 20,000. And the mass is what, 1,000. And you're gonna get that A is equal to 20 meter per second square. Okay, so we know that A is 20, so we can just substitute everything back into here. The force is 20,000. A is what, 20, come in, 20. So you're gonna get, and the times outside. So 2 times 2 is 4, and you have 5 zeros, so 4 times 10 to the power 5 t. Okay, that is how you get this answer. Not too hard. Question 17. An athlete pushes against a machine with a force that varies with time as shown in the first graph. Also, the velocity of the athlete's arm acting in the same direction as the force varies with time as shown in the second graph. So you have a varying force and you have a varying velocity. So what is the power applied at t equals to 0.1? So I'm pretty sure you just go to t equals 0.1, you find the force, and you find the velocity. So at 0.1 seconds, the force is obviously 800, right? So force is equal to 800 newtons. And at 0.1 seconds, you would want to find the velocity, which is somewhere over here, right? So as you can see that it's increasing constantly. So we want to find the velocity at the 0.1 over here. How would you do it? You would need to use some math, right? You can find the equation of the velocity as a line and then just substitute 0.1. Or you could just say 0.3 gives you 20. So 0.1 would give you x, right? And cross multiplying, you'd get 2 divided by 0.3. And you're going to get 20 over 3. So 20 over 3 times 800, you get this as your Power in kilowatts, it's 5.33. The maximum power developed during the 0.3 second time period is what? So to find the maximum power, remember again, power is equal to force times velocity. Okay, so our velocity is increasing over here, but you have to kind of think about it. At what instant are we going to have the maximum power? When will we have it? So we found the power over here at 0.1. So you can kind of see that the power is increasing because the velocity is increasing, right? So you're going to see that the power is obviously going to continue to increase until over here at 0.2, the force all of a sudden starts to decrease. So if you think of it, your maximum power will be over here because you're increasing until you start decreasing the force. The velocity is still increasing, but your force all of a sudden starts to decrease. So since your force starts to decrease, your power will what? Decrease. So since here we're increasing, then all of a sudden we change direction and start decreasing. You're gonna say that the maximum power is over here at 0.2. And how do we find the power at 0.2? The same way you found the power at 0.1. So you need to find the velocity at 0.2 because power is equal to force times velocity. The force is still 800, so we're gonna do 800 times the velocity over here. Suppose 0.2 is here, you would need to find the velocity. So we know that at 0.3 seconds, you have 20 meters per second. At 0.2, we don't know how many. Okay, so let's do it. 20 times 0.2 divided by 0.3. You get 40 over 3. So your velocity is 40 over 3. So the power will be equal to 800 times 40 over 3. And you should get, in kilowatts, 10.66666666. So to one decimal place, it's 10.7. Question 18. When the driver applies the brakes of a light truck traveling at 40 kilometers per hour, the truck skids 3 meters before stopping. How far will the truck skid if it's traveling at 80 kilometers per hour when the brakes are applied? So you are talking about the distance over here, and you're saying that, oh, we have a change in kinetic energy, right? So remember, ME1 plus work external is equal to ME2. Someone will say, oh, use the work energy theorem, just say W is equal to delta K. I'm going to use this, I'm going to get there, but give me a second, okay? ME1 is, there's no change in potential energy, so we can say the only thing composing the mechanical energies in this case, since there's no change in height, whatever, we're only going to have kinetic energy, okay? So you can have half times, let's just say, let's call it the kinetic energy, half times m times the velocity squared. Even though it's in meters per, in kilometers per hour, just keep it for now. Okay, plus W external is equal to ME2, which is, again, the kinetic energy is going to be now 80. We're going to say half times m times 80 squared. Why I'm writing this is I kind of want you to kind of see. Let's move everything to one side. W external is going to be half m times 80 squared plus half, half m times 40 squared. So if you factor out half m, and I'm just doing this so you can kind of understand, I'm going to make one conclusion at the end and you're going to use that to solve later. Factor out half m, you're going to get half m, 80 squared. What's 80? 80 is 2 times 40 squared minus 40 squared. So, okay, if you take 2 squared, you're going to get W external is equal to half m into 2 squared is what? It's going to be 4 times, keeping the 40 inside the square. I took the 2 outside the square, so I had to square it, okay? Minus 40 squared. So as you can see here, the change between these two is this square, okay? Changes by a square, okay? I know what I'm saying kind of doesn't make sense, but I did all of this just so you can kind of see that the kinetic energy here, when you change by a certain velocity, you doubled it, right? You multiplied by 2. Therefore, the change in the work will be multiplied by 2 squared. Okay, so if it was 3, it's not going to become 6 because you doubled the velocity. No, it's going to be 3 times 2 squared, which is 12. Okay, so that's why it's 12 meters. So if you want to kind of like write this down as a rule, if you look here, work is equal to change in kinetic energy. So therefore, force times distance is equal to half mv squared. So since these are constants, we're going to cancel this. You can say that F is directly proportional. Since the force also is constant, that means the distance is directly proportional to the velocity squared. Okay, that's it. Change in velocity squared. Okay, so the change in velocity is times 2, so directly proportional to 2 squared. It will be times 2 squared. So 3 times 4, which is 12 meters. You can use this conclusion in the exam if it comes like this. Maybe they change it differently. You can use this conclusion. It's directly proportional to velocity squared. Change in velocity squared. That change in velocity, I don't mean يعني final minus initial. No, final divided by initial. Okay? Anyway, question 19. A force of magnitude 50 newtons acts on a box at an angle of 30 degrees with the vertical. The work done by the force to move through the box of a distance of 5 meters is what? Okay, this is very nice. Very, very easy, very cheeky. All you have to do, work is FD cosine theta, right? So the force, 50, times the distance, 5, times cosine 30. Very simple. Remember. Okay, you get to the, whoa, 30 degrees with the vertical. Okay, that's a funny one. Okay, nice. That's so nice. Whoever wrote this thinks they're smart. They think, oh my god, I'm tricking students. Oh my god. So 30 degrees with the vertical. So it's gonna be like this, 30 degrees. So obviously here it's gonna be what, 60 degrees. And work is just gonna be equal to F times distance times cosine theta. But theta has to be between the x-axis and the force. Okay. So force in this case 50 times distance 5 times cosine 60, 125. Very easy. Question 20. It's 7 p.m. I've been recording since like 5. A box of mass 3 initially at rest acted upon by a net horizontal force of magnitude 15. The final speed is after 12 meters is what? Okay, nice. So remember, I don't like using W equals delta K. Always ME1 plus ME2. Sorry. ME1 plus work external is equal to ME2. Okay, always, this is what I use. Anytime you have any change in energy, I always use this, and there's an external force. What is ME1? It's 0. Okay, there's no change in height, so there's no potential energy change. W external, since we're horizontal, that's why there's no height change. W external is W external equals ME2, which is half times the mass, 3, times its velocity. We're trying to find it. So what do we know? We know that the force is 15 and the distance is 12. So we know what the work is. So the work is force times distance times cosine theta. Theta is 0 because it's a net horizontal force, and cosine 0 is just 1. Okay? So force times distance, so 15 times 12 equals 3 over 2v square. And you can just do this on a calculator. You should get 121 on the left after dividing by 3 over 2. You get 120. Oh, yeah, okay. If you square root this, you're going to get approximately 11. Okay, 10.95. So to the nearest integer, it's just going to be 11 meter per second. Question 21. A package of mass 15 is pushed along a straight line across a smooth horizontal floor by means of a constant force of 12 newtons. The package has a speed of 3 when it passes through A and the speed of 5 when it reaches point B. The distance AB is equal to what? Okay, so again, same thing. ME1 plus ME2. So, ya Allah, ME1 plus work external is equal to ME2. Simple as. Since we're working horizontally, there's no change in height, so there's no change in potential energy. So the only thing that composes the mechanical energy will be its kinetic energy. Initially, we're at 3 meters per second, so the initial kinetic energy is not going to be 0. We're not starting at rest, we're starting at 3 meters per second. So half times m times v squared plus w external equals me2. Again, no change in height, so there's no potential energy. So the only thing that composes me2 will be its kinetic energy. And it gives us speeds 5, so it's going to be half times the mass, 15, times its velocity squared. Okay, so we're going to get the W external is equal to, subtracting this by this, 0.5 times 15 times 25 minus 0.5 times 15 times 9. You're going to get 120. So W external is 120 joules. Type. Here's the thing, we want the distance. They told us what the force is, so we know that work is just force times distance, so it's equal to 120, and we know the force is what, 12, so 12 times d is equal to 120. If you divide 120 by 12, you're gonna get d is equal to 10 meters. Very easy. Question 22. A spring of spring constant K obeys Hooke's law. where F is equal to minus kx. And F is the variable force exerted by the spring, and x is the displacement of its free end. A particle attached to the spring extends it from natural length to an extension A as shown below. Okay. What? Okay, yeah, I get it now. So this is the f axis, this is the x axis. You're extending the spring since they use negative kx for they're using this. Okay. So what is the work done by the spring on the particle? Okay. Obviously, the work done by the spring. Anytime you have an fx graph, they're asking for the energy by the spring, the work done on the spring, work done by the spring. Bro, all you do what? What do? You just find the area. If it's a graph, okay. If it's an fx graph, remember work is equal to integral fx. Integral f dx. Which is also equal to the area under fx graph, right? Type. Yellow. What's this? This is a triangle. Its base is a. Its height is what? Over here, negative k. And since it's a triangle, base times height over 2. So you're gonna get this, the way they wrote it here, it's just negative ka squared over 2, which is just negative half ka squared. That's it. And this is just the exact same as our rule half kx squared, because they use negative kx. And also, no, because they're saying by the spring, not on the spring. By the spring, you make negative, by the way. That's actually one of the rules, but we never really used it, okay? So without actually looking at the graph, you can just say this عادي. But don't memorize, use this method, it's way easier. Okay. Next question. Question 23. A diesel car engine develops a force of 4 times 10 to the 3 newtons when the car is traveling at 25 meters per second. What's the instantaneous power? Very nice, very easy. Power is equal to just what? You have the force, you have the velocity. P is equal to what? Fv, right? So you just do force 4,000 times the velocity 25, and you get the instantaneous power. That instant is in kilowatts, dividing by 1,000 and 100. Question 24. A man of mass 80 kilograms climbs up 25 stairs, each of height 20 centimeters in 20 seconds. What is the power of the man? Okay. Power, you have the time, so we're pretty much going to use, you should know that we're going to use work divided by time. We know that he's climbing up 25 stairs up a height, so we know that there is a change in height. So what's going on? The work done is going to be equal to, same thing, what we always do, we say me1 plus plus work external is equal to me2. That's it. Always, if you want to find the work done, you have any change in energy, height, whatever, always use this. Okay, I've been using it almost every question now. me1, initially he's at the 0 point and he's at rest. So his initial kinetic energy and potential energy will be 0. So me1 is equal to 0. Work external will be work external equals me2. What's the final mechanical energy? Again, he's just going up height. It's not saying he's running at any speed. So his mechanical energy will have 0 kinetic energy, but it will be composed of potential energy. What's the potential energy? Mgh, right? So let's do it. Work external is equal to the mass 80 times g, which is 10 times the height, which is what? How many stairs? We have 25 stairs, so 25 times the height of each one is 0.2 meters, because it's in 20, we're going to make it 0.2 meters. So 25 times that. So let's take a look. We're going to get that the work is 800 times 25 times 0.2. You get 4,000. So the power will be equal to the work divided by time. So the power will therefore be 4,000 divided by 20 seconds. And should be 200 watts, yeah. 200 watts. Very nice, very easy. هيك بنكون خلصنا. Thank you so much for watching. And good luck in your exam.